NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a system of two linear equations in two variables. We will compare common methods, then solve a specific example using the elimination method, verify with substitution, confirm with Cramer's rule, and finally visualize the solution on a graph. Here is our general setup. First, the label example appears. Then the general system in bold, orange math. ax plus by equals c, and a prime x plus b prime y equals c prime. There are several standard solution methods. We list them now: elimination, scaling, substitution, Cramer's rule, and the graphical method. Example: we will solve a system of two linear equations using the elimination method, following the exact algorithm from the prompt. Problem statement: solve the system using the elimination method. Rule: elimination method. Multiply equations to align the coefficients of one variable, then add or subtract to eliminate that variable. Step 1. Multiply the first equation by 3 and the second equation by 2 to align the y coefficients. 3 times the first equation gives 15x plus 12y equals 3. 2 times the second equation gives 6x minus 12y equals 4. Rule: addition of equations. If two equalities hold, their sums also hold. Step 2. Add the two new equations to eliminate y and solve for x. Rule: division property of equality. Dividing both sides by the same non-zero number preserves equality. Step 3. Divide both sides by 21 to get x equals 1/3. Rule: substitution. Replace a variable with its equal expression in another equation. Step 4. Substitute x equals 1/3 into the second original equation, 3x minus 6, y equals 2, then solve for y. Example: we will solve the system using the elimination method, exactly in the order shown on screen. First, display the problem. Rule: elimination method. Multiply to align coefficients so that one variable cancels when we add. Step 1. Multiply the first equation by -3. Add the equations to eliminate a variable. Step 2. Add the two equations to eliminate x. Rule: solve the linear equation for y. Step 3. Divide both sides by -9 to find y. Rule: substitution method. Step 4. Substitute y equals -4 into the first equation. Rule: solve for the remaining variable. Step 5. Divide both sides by 2 to find x. Final answer: x equals 3 and y equals -4. Nice work. Quick challenge. The two equations are 2x plus 5, y equals -1, and -10x minus 25, y equals 5. We will follow the elimination method exactly. Step 1. Multiply the first equation by 5, so that the x coefficients line up with plus 10x and minus 10x. Step 2. Add the two equations to eliminate x and y simultaneously, which yields 0 equals 0. Second problem: 3x minus 4, y equals 23, and -2x plus 7, y equals -24. Step 1. Align x by multiplying the first equation by 2 and the second equation by 3. Step 2. Add the equations: 6x minus 8y plus -6x plus 21y equals 46 plus -72, giving 13y equals -26. Step 3. Substitute y equals -2 into the first original equation to solve for x. Final results. Example 1 has infinitely many solutions because the equations are dependent. Example 2 has the solution x equals 5 and y equals -2. Quick challenge. If you had two equations with the same left side but different right sides, what would the result be? Take a moment to think about it. We will solve the system using the elimination method, then confirm by substitution. First, show the word example and the system in orange. Elimination method. Multiply one equation to align coefficients, then add to eliminate a variable. Step 1. Multiply the first equation by -2 to cancel x when we add. Add the two equations term by term to eliminate x. Step 2. Add the left sides and add the right sides. Combine like terms to get 5y equals 0, so y equals 0. Substitution. Replace y with 0 in one original equation. Step 3. use x minus y equals 1. Plug y equals 0 to get x equals 1. Our solution is the ordered pair x equals 1, y equals 0. In this lesson, we solve a system of two linear equations using the elimination method, exactly following the structure shown on screen. Here is our example. The orange system is the problem statement. Step 1. We multiply the first equation by -2 and the second equation by 3, so that the x terms cancel when added. Step 2. Add the two equations. The x terms cancel, leaving 19y equals 19, so y equals 1. Step 3. Substitute y equals 1 into the second equation and solve for x. Therefore, the solution to the system is x equals 2 and y equals 1. Quick challenge. Verify the solution by plugging x equals 2 and y equals 1 into the original equations. In this video, we will solve a system of linear equations using the elimination method. We will follow the exact sequence of steps shown in the reference solution. First, display the example and the system. Step 1. Rewrite the first equation as y minus 3 has x equals -5, and multiply that equation by -2. This gives -2y plus 3x equals 10. Step 2. Add the two equations to eliminate y. On the left, -2y plus 3x plus 2y plus 5x, and on the right, 10 plus -3. That simplifies to 8x equals 7, so x equals 7/8. Step 3. Substitute x equals 7/8 into the second equation to find y. 2y plus 5 times 7/8 equals -3. 2y plus 35 over 8 equals -3. 2y equals -3 minus 35 over 8. Replace -3 with -24 over 8, giving 2y equals -59 over 8. Finally, divide both sides by 2 to get y equals -59 over 16. Therefore, the solution that satisfies both equations is x equals 7/8 and y equals -59 over 16. Quick recap. Multiply the first equation by -2 to match y coefficients. Add the equations to get 8x equals 7. Solve for x, then substitute back to find y. Example. We will solve for x and y in the exponential equation, where the bases are 2 and 3. The equation is 2 to the power of the quantity, 2x minus y minus 2 equals 3 to the power of the quantity, x plus y minus 1. Because the bases 2 and 3 are different and both positive, the only way these powers can be equal is if they both equal 1. That happens when each exponent is 0. Rearranging each line isolates the constants on the right. We have 2x minus y equals 2 and x plus y equals 1. Add the two equations. The negative y and the positive y cancel. Left side becomes 3x and the right side becomes 3. Divide both sides by 3 to get x equals 1. Substitute x equals 1 into the second equation. X plus y equals 1. Then y equals 0. Let us check. 2 times 1 minus 0 minus 2 equals 0. 1 plus 0 minus 1 equals 0. Both exponents are 0, so each side is 1. The solution is correct. Final answer x equals 1 and y equals 0. In this lesson, we will solve a classic two-variable mixture problem using elimination and substitution. We have two mixtures of two ingredients. Mixture A has 4 units of type 1 and 3 units of type 2 and costs $200. Mixture B has 3 units of type 1 and 5 units of type 2 and costs $170. Let x be the price per unit of type 1 and y be the price per unit of type 2. Our goal is to find x and y. Each box labeled x contributes x dollars. Each box labeled y contributes y dollars. So mixture A gives the equation 4x plus 3, y equals 200. Mixture B gives 3x plus 5, y equals 170. To eliminate x, we can create opposite coefficients. Multiply the first equation by -3 and the second equation by 4. This gives -12x minus 9, y equals -600, and 12x plus 20y equals 680. Now, add the two equations together. The x terms cancel. We obtain 11y equals 80. Therefore, y equals 80 over 11, which is about $7.27 per unit. Next, substitute the value of y into one of the original equations. For example, 3x plus 5y equals 170. 3x plus 5 times 80 over 11 equals 170. That simplifies to 3x equals 170 minus 400 over 11, which is 1470 over 11. Divide by 3 to get x equals 490 over 11, approximately $44.55 per unit. Let's quickly check the solution by plugging back into each mixture. 4 times x plus 3 times y equals 4 times 490 over 11 plus 3 times 80 over 11, which equals 200, and 3 times x plus 5 times y equals 170. The solution checks out. Final answer x equals 490 over $11 per unit, and y equals 80 over $11 per unit. Example: we will follow a clear 6-step algorithm to solve an ages problem by forming and solving a system of equations. The sum of Alex's age and his father's age is 70 years. Their age difference is 26 years. Let x be Alex's age and y be his father's age. Solve for x and y. Step 1. Write the system of equations. We state the two equations exactly. Y plus x equals 70 and y minus x equals 26. Step 2. Add the two equations to eliminate x. When we add the left sides and the right sides, we get 2y equals 96. Step 3. Solve for y. Isolate the variable by dividing both sides by 2. Y equals 48. Step 4. Substitute the value of y into the first equation. Replace y with 48 in y plus x equals 70. That gives 48 plus x equals 70. Step 5. Solve for x. Isolate x by subtracting 48 on both sides. X equals 22. Step 6. State the final ages and check. Alex is 22 years old and his father is 48 years old. In this lesson, we will follow a clear, image-inspired, step-by-step process to solve two algebra problems by building and solving systems of equations. We begin with the example label, then show the problem statement. Step 1 is a reminder about solving systems of equations. When both equations are written as y equals ax plus b, substitution works well, otherwise elimination is often convenient. Now we convert the fraction conditions to linear equations. Add 3 to the numerator and denominator equals 3/5 gives 5 times x plus 3 equals 3 times y plus 3. Subtracting 3 version equals 1/3 gives 3 times x minus 3 equals y minus 3. Distribute and gather like terms. 5x minus 3, y equals negative 6. 3x minus y equals 6. Use elimination. Multiply the second equation by 3 to match the y coefficients. Then subtract the first equation to solve for x. That gives 4x equals 24, so x equals 6. Substitute back into 3x minus y equals 6 to get y equals 12. Therefore, the fraction x over y equals 1/2. Next, a second example with a 2-digit number. The sum of its digits is 15. Swapping its digits increases the number by 27. Write the number as 10x plus y. The swap number is 10y plus x. Swapping increases by 27, so 10y plus x equals 10x plus y plus 27. Simplify the second equation to negative 9x plus 9, y equals 27, which reduces to negative x plus y equals 3. Thus, y equals x plus 3. Substitute into x plus y equals 15 to get 2x equals 12, so x equals 6 and y equals 9. Therefore, the 2-digit number is 10 times 6 plus 9, which is 69. We have completed both problems following the same structured approach. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.